Hi everyone, welcome to yet another episode of Risk Grustlers, where we look at insights from the trenches on security and risk management. Today we have Sounil Yu. Sounil, why don't you introduce yourself to our audience and talk a little bit about your journey?
Sure, thanks. Hi, I'm Sounil Yu, and I'm currently the Chief AI Officer at a startup that I created called Knostic. I used to be the Chief Scientist at Bank of America. I've spent about 30 plus years in security. I guess one of my claims to fame is I wrote a book called The Cyber Defense Matrix. It's a mental model that helps a lot of people really understand how to navigate some of the challenges and the intricacies of cybersecurity.
Right. And what led you to the journey in cybersecurity? Where did you get started? A lot of our viewers are actually young engineers trying to break into cybersecurity or young cybersecurity professionals trying to learn from people like you. So would love to talk about your journey a little bit.
Yeah, I guess what first thing is what kind of engineers? Like for example, I was a system engineer in the sense of a endpoint, like managing.
What kind of engineers do they need to be to break into cybersecurity? Let's start from there.
Yeah, so actually, the cyber defense matrix that I mentioned earlier. Let me explain that real quickly because I
Sure.
think that'll help you understand what
Absolutely.
you mean by what kind of
Absolutely.
engineer. So it's a 5x5 matrix, and it consists of the two dimensions. One dimension is the 5 things that we do in cybersecurity: identify, protect, detect, respond, recover. It's also called the NIST cybersecurity framework. The other dimension are 5 asset classes or 5 attack surfaces or 5 things that we care about: devices, applications, networks, data, and users. So when we talk about engineering, well, are we engineering devices? Are we engineering applications? Are we engineering networks? Are we engineering data? Are we engineering users? Well, that doesn't quite make sense, but you get the idea. And the perspective here is each of those has a certain discipline that people may start with. So, for example, systems or device engineering may look like managing Windows workstations. Application engineering is, of course, like software engineering. Network engineering, has its own sort of discipline as well. So what was my background is I started in both endpoint engineering as well as network engineering, but I also was a software developer too. I had comp sci as a background, and so I've had a pretty broad set of skill sets that I think are needed to be able to tackle this very complex space, this very interdisciplinary space called cybersecurity. So the cyber defense matrix means we're covering all 5 of those different types of assets. And we need skills and we need controls and we need architecture for all 5 of those assets. But usually people only come in with a skill set in one of those disciplines.
And how fungible are they? So for somebody who's on a particular track to begin with, say network, and if they want to migrate to, say, applications, the cloud, or GRC, which
Mhm.
is, I would say, security adjacent in some sense, how do people make that shift? And what stage of their career is there still room for them to make that shift?
Well, our brains are very moldable. So our ability, or, very plastic, so to speak. And so one's ability to shift careers or shift disciplines, some of it requires you to have to reset your expectations in terms of where you are from a level standpoint. But that said, I would argue that what I've seen is that generally speaking, you start with a certain technical discipline and you anchor your credibility and your understanding and your ability to deliver at a technical level based on one of those domains. But over time, you are expected to understand larger aspects of how the business works or how to run teams, how to lead teams. And so those sort of skills become much more important mid and late stage within your career. And those skills are really not necessarily technical skills. They're people skills, right? They're skills that you develop just by working in a business environment.
What are some examples of people skills that become relevant or softer aspects to the job that people should be well aware of?
Sure. One easy one is just managing difficult conversations, right? It's a life skill, right? These are all life skills. And it's not something that you necessarily, you can read a book about it, but at the same time, you learn it through just living life and becoming more mature as an adult. But like managing difficult conversations, there's a lot of really great books in this space that have nothing to do with cybersecurity, but are so essential in being able to actually run a very effective cybersecurity team.
Got it. Just shifting gears a bit, Sunil, a lot of us vendors are now actually using agents, and agents has come to mean a lot of things of late, and every vendor on the floor is talking about AI and agents in some sense.
Yeah.
But just taking a generally accepted market view of what agents are today, a lot of us are actually using agents to deliver certain outcomes to our customers in
Mhm.
cybersecurity and otherwise. Now, the way we see this, there are two components of making or allowing customers to trust agentic outcomes. One is, and so dependability has two flavors to it. One flavor is reliability. Can I trust the outcome that the agents are generating? That outcome could be an answer, outcome could be an action, it could be an inference, but can I trust what is being given to me through an agent? And the second component is the vendor being responsible with my information?
Mhm.
Because depending on the criticality of where the agent hits you, it could be business critical data, it could be PI, it could be PHI. but there's some sort of an interface present. How can I trust my vendor to be responsible with it, right? Let's talk about the second component of dependability here. Large companies have big teams, lots of resources to experiment with multiple things. But when it comes to small companies, right, we don't want this to become a gate opening criteria to an extent where it becomes prohibitive for small companies or mid-sized companies to punch above their weight when they're trying to deliver agentic outcomes. What would be some of the hygiene controls or guardrails that are most pragmatic to at least begin your agentic security with? And that I think will be very valuable for our viewers, many of whom are actually mid-size or small and mid-size companies that are either AI native or building meaningful agentic workflows into their core product.
Okay, so let's unpack that. There's a lot to unpack there. So first, you were asking about is just general hygiene. Let's talk about agents in a moment. We'll talk about just general how we determine best practices within the context of security that now has become so evident that you should do that everyone should be doing it.
Yeah.
Well, the first problem with that assertion is that which you call basic is oftentimes actually still hard to do. I'll give you an example, and this is based on data from insurance providers.
Sure.
There's a great study by Marsh McLellan, by a researcher at Marsh McLellan. His name is Scott Stransky, and he researched all this data about what are the different parameters of a security program, large, small, whatever it is, that ultimately led to a certain type of outcome. The outcome being that they get breached.
And just to clarify, when you talk about large, small, medium, what does that mean? So is it the complexity of the security program or the size of the company that's
Size of the
deploying
company.
Okay, got it.
Yeah. Which generally correspond to then the size of the team as well.
Got it.
Anyway, so he evaluated all these different parameters and found the ones that move the needle the most. And so you could argue that those that move the needle the most would be those things that we should focus on as the best hygiene. Yet one of them was hardening your identity system, or basically for many organizations, your Active Directory environment. But that hardening is extraordinarily hard as well. And so the expectation that a small organization can do that is really actually not a good expectation.
Could you pick a couple of examples there? I mean, why does it become hard for small organizations to do hardening there?
Just purely because of lack of skill sets, right? You have talent, you need talent that
It's an expertise gap.
Yeah, it's an expertise gap. And if you're managing, for example, your own Active Directory instantiation, you're not going to necessarily want to have staff just to manage that function.
Right.
So really if you're a smaller organization, you really need to just outsource that to Microsoft, because they're the ones who have that skill set, or to outsource it to Okta, or to whoever it is that
or an MSP, as the case may be. Yeah.
Or an MSP that has the skill sets and the staff to do that. So, but those are kind of like, hey, make sure you do that, because that was the number one factor in this study from this insurance broker. But there are other ones. For example, having not just MFA, but having MFA for specific privileged users, specifically admins. And then subsequently, also another corresponding aspect of MFA is make sure that you have MFA in front of your critical applications. At this point, I would say really data-driven perspectives of what constitutes good hygiene that actually reduces risks as it relates to insurance payouts.
So this is very horizontal, AI or otherwise, right? This is something that's just becoming more talked about as companies face a top-down push to adopt more AI, but it's something that's already been...
So now let's talk about it in the context of AI. So I was talking about hygiene in a very general sense, but now how do you translate that hygiene into an agentic system?
How an agentic system, from the point of view of security, right? How does an agentic system fundamentally differ from a more traditional, like a software API-based kind of system? What makes it more complex or different to begin with? And then maybe we can build on top of that and talk about what security practices need to be different in the agentic era.
Okay, so let me reset the question in a slightly different way. So let me go back to my earlier comment about like where I developed my talent or skill sets in cybersecurity. I am a very strong believer in something called mental models. We are, a lot of us are wanting to increase competence in things like cybersecurity. And mental models, in my view, is the API for our brains. It enables us to very quickly accelerate our ability to learn and to be able to communicate with one another. So if we have a shared mental model, then it allows us to communicate much faster. Well, one of the mental models I shared earlier was the cyber defense matrix. I'm now going to share with you another mental model. Many people may already be familiar with it, but I'll answer your question using that mental model.
Sure.
Okay. So the mental model is called the OODA loop. Observe, Orient, Decide, Act. OODA. Okay. I'm going to make some slight modifications. Instead of observe, I'm going to call it sensing. Instead of orient, I'm going to call it sense making. So sensing, sense making, decision making, acting. Okay. Now, of those 4 steps, I'm going to walk through 3 different scenarios. The first scenario is when I let the machine do sensing and acting, but I, as a human, reserve the right to do sense making and decision making. So, in other words, I will say, I trust this sensor. That's my sense making. And based on the results of that sensor, I'm going to act in these particular ways. A classic use case is, let's say, automated patching. I trust Microsoft and the patches that they offer. I trust them enough that I'm willing to patch only workstations. Okay. In that particular case, I want a certain set of controls. The first control is, again, trustworthiness of the sensor. And on the action, I want a big red stop button that says stop, or maybe even a reverse gear. I also want to tightly scope my actions.
Yeah.
Okay, case number 2, I now add sense making. So now I have sensing, sense making, and acting. This is a classic SOAR use case, or what's called security orchestration and automated response. And in this case, I am still letting the machine do sensing and acting. So I need my controls from the case number 1. But because I've added sense making, I need new controls around sense making. How do I ensure that the machine is doing sense making in a reliable, predictable sort of way? Okay. The third case is when I now let the machine also do decision making.
Yeah.
Okay. And this is squarely where agentic AI is in.
Absolutely.
So the question that you were asking, like, what's new and how is it different than your traditional ways of automation and whatever else it might be? Most of our traditional ways of automation is either case 1 or case 2.
Yeah.
Agentic is now adding decision making into
The
the
fourth
fold.
dimension to it. Yes.
And so with decision making, now the question is, what are the new additive controls you want to have around decision making? And the mental model, again, that I use to think through what those controls are, imagine if you just hired 100 interns. What would you expect? Yeah, well, first of all, as a manager of 100 interns, you don't really have much time to give to each one. Okay, you give them some general instructions, and they go off and try to accomplish whatever tasks that you've given them, and you hope for the best. But the reality is,
That's a great analogy.
yeah, 95% of them, they're gonna fail. They're gonna break things. They're gonna create security alerts. They're gonna do stupid things.
They're even going to manufacture things to save their skin, like agents hallucinate.
They'll hallucinate. They'll lie to you. Anyway, you get the idea. But there's 5 of those interns that will do something amazing.
Yeah.
Okay. And here's the thing that I think is really fascinating once you look at this model. What's really fascinating is we think that the value of the agentic workflow is the action that this workflow is accomplishing. But if you think about it deeply, the real value is actually the workflow itself. Okay. What new workflow did you just discover? Oh, you have 100 interns doing crazy things.
Yeah.
At the end of the summer, all those interns are gone. But what you're going to keep are the things that these 5 interns discovered a new business process. And you say, wow, we should do that over and over again. But not in an agentic workflow, but rather in case number 1 or case number 2. In other words, you decide, we humans decide, this is the new business as usual workflow.
Got it.
And now let's implement that in a very deterministic, repeatable way in either case number 1,
Certainly.
okay, or case number 2.
Yeah.
Where we still reserve the right to
creates a funnel for experimentation at a much larger scale than what human intends.
Absolutely. The third case where you let a machine do decision making, you should treat those as experiments.
Got it.
Okay. If you think about it, hiring 100 interns is an experiment, and you don't necessarily. I mean, if all 100 are amazing, great. But generally, you go in from a perspective that some are going to fail, some are going to do, some are going to do well. You hope for the best, but you also expect the worst, and hope that out of that you get essentially. In many ways, I see interns as an investment in process.
Yeah.
Okay. And we don't really invest in process in businesses today.
So I want to play ball to your personification of agents, which is very interesting. It's a great mental model. I haven't heard a better analogy, to be honest. Now, how do you manage oversight on interns? How do you oversee their work while also not being too involved? Because it kind of defeats the purpose of having interns in the first place, right? So how do your governance processes change when you're engaging with agents versus traditional software?
Yeah. So the reality is that we have to have some sort of hierarchical mechanism. Like, we as a human cannot manage 100 agents.
Absolutely.
Right?
Yes.
So what we have in our world, of course, in the human world, is we have this notion of span of control.
Yeah.
And span of control is somewhere between 8 to 12 people.
Yeah.
8 to 12 agents. Okay.
Got it.
And maybe those agents can oversee, I don't know what the span of control for an agentic manager looks like. I don't know if it's going to be also 8 to 12 or it may be 100. I'd be curious to see what actually becomes ideal. I wouldn't be too shocked if it ends up that the ideal ratio is, again, 1 to 8 or 1 to 12 or something like that. Even machine agents, I mean. So at some level, today, again, we have an existing model of how we look at management and management responsibilities, and we say, you know what, if you have more than 12 people, you as a manager of your resources may not do as well as somebody who has who manages only 8 people. But at the same time, if you manage only 4 people, then maybe we should combine different teams together and so on and so forth. So anyway, there's these models that we have in terms of how we do divide up management responsibilities. And I think in the context of a human having to review the work of an agent, if you have an agent that oversees other agents,
Yeah.
then you'd be reviewing those manager agents, if you will. Another mental model that I use to help us understand how to think about the problem of AI or the problem space of AI is a mental model called the DIKW pyramid. And it stands for data, information, knowledge, and wisdom. And what we've seen is this progression of technologies that have moved us up to the knowledge age. You'll hear a lot about how these AI systems are really knowledge systems. So now imagine, if you will, I can replace the word AI with the word knowledge. And if I do that, now I can anchor my understanding of the AI problem space. Because we know the problem space for, let's say, data. Well, data quality, data privacy, data engineering, data security. We can apply those suffixes to information and they still work. And when you apply it to knowledge, you now have the problem space for AI. So I'll give you an example. Like, what exactly is knowledge quality? Well, you know what data quality is, but what is the knowledge quality problem? Well, the problem of hallucinations is a knowledge quality problem. Okay. And now tackling it, you may wonder, okay, well, I know how to tackle data quality. How exactly do I tackle this concept of knowledge quality or hallucinations? Well, it turns out your technical controls will actually fail, but maybe your people and process controls can roll forward. The individuals that you have who are supposed to oversee data quality, maybe they could also be applied to address some of the challenges around knowledge quality or hallucinations, or whatever governance processes you might have to manage data quality. Might they still work for knowledge quality? And generally speaking, I think the people and process side of it do carry over, but the technology fails. I'll give you an example of how the technology fails. Let's say you have perfect data quality. Will you still have a knowledge quality problem? Will you still have hallucinations? Of course, the answer is yes, you will, right? So even if you made it perfect, you still have a new problem that your technical controls couldn't address. I'll give you another example.
Sure.
Knowledge privacy. Well, what's that? How's that different than data privacy? Well, this became pretty evident during Cambridge Analytica, where they were able to infer our political affiliations. There's no field in Facebook that you can turn off that says, don't, share my political affiliation. Yet that was exactly what was derived from all our data. So you can there's no data you can turn off per se. It's from the inference ability. And so at the end of the day, it serves as the DIKW pyramid helps us understand the shape of the future, the shape of the problem space for AI. And this is how I figured out the kind of problem that I think we're going to face with knowledge security. Okay, so we know data security is. What exactly is knowledge security? Well, knowledge security is the oversharing problem that we see when you first roll out an LLM, and all of a sudden it overshares all this content because our permissions are incorrect. And so what we want to do is to say, okay, let me bound that appropriately. And so this notion of knowledge security is creating proper segmentation in your knowledge space. And so that is, I think, the new knowledge security or AI security problem.
So when you talk about security in this context, right, and good governance practices, in the older world, hygiene was hardening of devices, for example, right? Very hygiene, right? Irrespective of whether using agents or not. When we add the complexity of agents on top of traditional software, what additional hygiene security practices sort of become the bare minimum expectation there? What complexity gets added there?
Yeah. Well, okay. So
like very obvious things like what am I leaking? What information am I providing to agents, right? Are are my agents any more privileged than the user that's overseeing them, right? Because they need to inherit the level of privileges or be below that. So what are some of those hygiene principles that companies should look to follow?
Yeah, these hygiene principles are not new, but they're hard to implement. One of the basic hygiene practices, of course, is least privilege and ensuring that somebody has only access to that which they should have. But
I think in implementing the principle of least privileges for humans are still easier, but there are ways to do this, not easy, and there's still a lot of ways it can fail. But doing it for agents is, I think, it's not talked about as often as it should, because the agent should not be any more privileged than the user that owns them. They shouldn't be used to jailbreak information that you would otherwise not have had access to. So, do you see some complexity surfacing there?
yeah, absolutely. So let's talk about it in two levels. First is the direct permissions issues that they
Yeah.
have. And a lot of times, even though we try to exercise least permissions, least privilege, we fail actually in that, and we give systems and people more access than they should.
Yeah.
Okay. Just because you give them more access and things work, you start removing access and now something breaks. Okay. So you just give everyone root or something like that. So anyway, at the most direct level, we oftentimes overprivilege things. But let's hypothetically believe that we have made that perfect. Okay, like the permissions are
The perfect
exactly
access control mechanism. Yeah.
yes, which doesn't exist, but let's assume it does, right? The emergent property of things like LLMs is the ability to infer things that you shouldn't necessarily have access to, but because you have access to things legitimately, you can add, 1+1, so to speak, and arrive at 3. Okay. So for the canonical example I give is, you don't necessarily want to give people access to layoff information, but could they infer that from legitimate access to future equipment purchases and future building space?
Hmm.
And the answer is you could, right? The inference can be wrong, but the fact is that you can still infer it, or rather you can have a machine or an agent infer that.
Yeah.
And that itself is problematic. And this is with perfect permissions. Okay.
Yes. Got it. That makes a lot of sense. Would you like to talk to our viewers a little bit about what Gnostic does and how it helps companies, as a closing note?
Well, that's actually that's the problem that we're trying to solve. We think that the ability for us to understand what are the boundaries for an agent need to be defined in a concrete way. We oftentimes say we need to give these large language models context, but what does that mean? And what kind of context are we talking about? And so what we do is we provide persona based need to know, so that an agent can have discretion, this power of knowing that it's okay, even if you have access to something like salary information.
Yeah.
If you're not supposed to really have that, in other words, if salary information was accidentally given to you, we don't want an LLM to say, "Hey, here's salary information. If you ask for it, your boss's salary, let's say, if you ask for it, because you don't really have a need to know. So you have access. You may not know you have access,
Yeah.
but because the LLM is very efficient at finding this stuff, it will find it for you. And
So it's like one of those disclaimers at the end of an email, and this information is privileged. If you accidentally have access to it, please don't receive it. Just ignore it completely.
right, you're supposed to delete it. Most people don't, but that's it.
Yeah.
Yeah, the idea behind a large language model is the large language model should actually adhere to that principle
Yes.
and say, sorry, I can't tell you, even if you have access.
Got it. Thanks a lot, Sunil. Thanks for taking the time to be here. And thanks for watching yet another episode of Risk Grustlers. We'll be back soon. Thank you.